Yes, sir. I'm content to see the screen, sir.
The screen is here. You can't still see it.
No, sir, I can't. Don't know if it's my
Who,
network.
who else can see the screen?
I think it's
It's
just
just
on his. I can.
Okay, so it's your network. Try to rejoin.
Okay, sir, let me just do so.
Okay, so we're looking at the graphs. The graphs. And we'll start with, we'll do them in example forms. Example 1. So we'll start with the sketch of sine. Sketch 1, f of x is equal to 1 plus 2 sine x plus pi over 2 on the interval on the interval 0 okay, let me change the interval on the interval negative pi over 2 less or equal to okay 2 pi. So we have a detailed sketch. The first thing that you need to know is that for a sine function, when they say sketch, the method that I feel is easy, if you understand the use of angles, is where from this one, when they say sketch, your task is just to get the period. The period will always be 2 pi over b. So I'm going to give a detailed structure which has these letters. It's also to get the scale. The scale will be the period divided by 4. It's also to get the horizontal shift. The horizontal shift. This is obtained as x is equal to negative c over b. We are used to such formulas because we've done the quadratics, we've done the polynomials, so you can see how they have fixed formulas. And then, so the question now is, where do I find b? Where do I find c? So the structure of a function that we are talking about here is in the form a sine bx plus c plus d. This is the setup that we have. So when you have this, then you say the period is 2 pi over b. Where is b? B is always the coefficient of x, of the variable x. The variable x in the graph of sine will only appear at one place. The C and the B, you can see how they are positioned. The P is the period. So when they say sketch, that's what you need. But in case they also ask you to find the amplitude, they say find the amplitude of this. You say it's the modulus of A. You've seen where A is placed. Find the vertical shift. The vertical shift is D. So you get D as it is. If it is positive, you get as a positive. If it's negative, as a negative. But A, you get A as positive always. That's why we bring in the modulus. So now you only get to these when they ask for them. If they just say sketch, just get these three first parts here. So let's go on and get the period. So the period here is going to be 2 pi over b, and our b is 1. So we just get 2 pi. And the scale, the period is 2 pi, and then we divide by 4, so we get pi over 2. Horizontal shift, we are saying it's negative pi over 2 over 1, which is just negative pi over 2. And then now you can sketch. So how do you sketch? Okay, you can just have a line. So far, you know your sketch is going to come here. So immediately you get, I have a question from Daniel.
Sir, sorry, I didn't get the point where you said that our B is 1.
So look at the position of B in this one. So keep your eyes here. Whenever you see a question, put this thing here in mind and compare for you to get the variables. I mean the values of A, B, C, and D. So what you're calling B is the coefficient of X. Now in this case, X is just standing alone, meaning its coefficient is 1. So B is 1 in this case.
Okay, I get the point. Thank you.
Okay.
Sir,
Hello.
so meaning we don't have D in this case, we don't have the vertical shift.
We have the number standing alone will always be D.
Which is 1.
1.
Sir, I also have a question.
Hello?
So the function you've written up there is for what?
This one here.
Yes, what says of that function?
So that's a general structure of the sine function. So now we're saying that all the sine functions have to appear like that. And when they are like that, you use those letters to help you get the period, the scale, horizontal shift, the amplitude, the vertical shift. For every sine function. Okay, so when you get the horizontal shift, you go to your sketch and start from there. Negative pi over 2.
Excuse me, sir. I'm currently behind where how you got horizontal shift.
Okay. Who else has a query here? Who else is behind
Me,
on this
sir.
problem? Where?
Behind.
Very much behind, sir, because at the office, I had to move out of the meeting, then rejoin. So I missed even the first part. So I'm just kindly asking if you can just repeat, sir.
So who else? I want to know so that I get the easiest way of coming out.
I'm also behind.
Me too, sir.
All right. Attended.
We have gotten it, sir.
I'm also behind, sir.
Okay. So the thing is this. Whenever you see a sine function, in whichever form you find it, the first thing to know is that it was supposed to come in this form. This is the original structure of a sine function. Okay. Now these letters A, B, C, D have got meaning. The same way we have a quadratic. Remember, a quadratic is in this form. Each piece of it has a meaning. It has a use. So what does that mean? This means that even what we have now in our question, we are saying for it to be called the general one, it must have a meaning so that we are able to apply it on any other function of the sine trig ratio. So whenever I see such a structure here, the questions that I need to answer in trigonometry, any sine function will have amplitude, it will have the period, any sine function will have the horizontal shift, it will have a vertical shift, and it will also have a scale. The question is, where do these come from? They come from the very function. The amplitude, the one we call the amplitude, is just the modulus of A. So every time they ask you for the amplitude, you go to the function and look for A. What is A in the function? A will always be the coefficient of the sine. The same way we say if you have ax squared plus bx plus c, later on you see a function of this form, 2x squared plus 7x plus 10. They ask you for A. What is A in this question? How do you look for A? You have known that A is the coefficient of x squared. So you go to x squared and get the coefficient. So you would say A is equal to 2. The very thing is what we do on the sine function. We've said that A is going to be the coefficient of sine. The actual sine, not just any other part. So if you give me a function of this nature, y is equal to -3 sine x, A in this function is -3. It is the coefficient of sine. And then my amplitude is not going to be -3. My amplitude will be the modulus of A. So it will be the modulus of -3, which is always +3. That's what we mean by the modulus. Second thing, the period. The period will be 2 pi, you know 2 pi is 360. So the period is going to be 2 pi over b. B is the coefficient of x. There will only be one x, just like there will only be one sine in that function. So the coefficient of x, in this case, if it was this case, the coefficient of x here is 1. So you would say 2 pi over 1. Horizontal shift, you get the inside, the angle, the inside of sine. You get the bx plus c equated to 0, and so for x, so you would get negative c over b. That's why we say that the horizontal shift will always be negative c over b. So if it was this question here, the angle is just x. So when you equate it to 0, you get that the horizontal shift is equal to 0. The vertical shift is the number standing alone, not multiplying sine, not an angle. It's just standing alone, whether to the right or to the left of that. Any number standing alone is called the vertical shift. And so we have named it. So here we are saying negative c over b. Here we are saying d. Then the scale is after you obtain the period you get, the period you divide it by 4. What you have is called a scale. A scale is the number that we use to determine the spacing in between numbers when you are sketching. Is that okay? We now want to apply this to our question. Example 1. What is the period? It is going to be 2 pi. If you want, you can list the a. So you say a in this question is equal to 2. B in this question is equal to 1. C is equal to pi over 2. D is equal to 1. So that if you need them, you just get them from there. So where we have 2 pi over b, we have 2 pi over 1, which is 2 pi. Where we have period over 4, it will be 2 pi over 4, which is pi over 2. Horizontal shift is negative c over b. Now c is pi over 2. So it starts by being negative. So negative pi over 2 over b. b is 1. So we get pi over 2 over 1. And remember, it must be negative. So we have negative pi over 2. The vertical shift in this case, if you wanted it, it is 1. That is our d. And the amplitude, the modulus of 2, which could just be positive 2. But now we are saying when sketching, all we need are just the 3 things: the period, scale, and horizontal shift. And your first number to be written on your sketch is the horizontal shift, negative pi over 2, as we have written here. The next thing is you start adding. You always be given an interval where you must sketch your graph. In this question, the interval is here. So this is the interval. The question is, how do we cover up this interval? You know, when you are sketching, sometimes you have things like this. You want to know, you want to sketch a function y is equal to x plus y. Some people may not just sketch this. They'll put up some numbers. You say, okay, 0, 1, 2, 3. Now, how do you know whether I should say 0, 1, 2, 3, or I should say 0, 2, 4, 6, or 0, 5, 10? What scale do you use? So now I'm saying in trigonometry, the easiest scale to use is where you just break the period by 4 so that you can get the critical points of the graph, the important points of the graph. So in this case, our scale has been found to be pi over 2. So we'll be adding pi over 2 to each number. Like we have 0, 2, 4. We're adding 2 to each number. So in this case, we'll be adding pi over 2 to each number. So we'll start from the horizontal shift. And to make matters well for our case, it's even our starting point here. So we'll keep adding until we get to 2 pi. So you say, okay, so negative pi over 2 plus pi over 2, you get 0. 0 plus pi over 2, you get pi over 2. Remember, pi over 2 is 90. So 90 plus 90, you get 180. 180 plus 90, you get 3 pi over 2, which is 270. And 270 plus 90, you get 360, which is 2 pi. So once you reach 2 pi, you end your case there. You now look for the y coordinates. So these are the x coordinates. So where are the y coordinates for us to have a full sketch? You go back to the function. It is f of x.
Sir,
Hello?
sorry to stop you. At how are we getting these intervals? This pi over 2 pi, 3 pi over 2.
So you stick to your scale. The scale is the number that you add to the horizontal shift to start getting the other numbers. So our horizontal shift is negative pi over 2. Then our scale is positive pi over 2. So we'll keep adding positive pi over 2 to every number until we get to 2 pi. So that our spacing in between is pi over 2.
Which numbers are we talking about?
The horizontal shift. Look, our first number to be written is the horizontal shift. From there, where do we go? We get the guidance from the scale. So we'll come to the horizontal shift and add the scale.
Oh, okay, sir, I get.
The number you get, you add the scale again. The number you get, you add the scale again until you get to 2 pi. Why 2 pi? In this question, we are told we must end at 2 pi. So sometimes your horizontal shift may fall outside the required interval for sketching. You start from the very number given. So you would put the horizontal shift and add without indicating on your sketch until you get to the number given, and then that's when you start indicating them on the sketch. So we'll have such examples. So now, once we have these are called the x coordinates. Now, for us to sketch, we need also the y coordinates so that we can have points. So how do we obtain the y coordinates? We have our function 1 plus 2 sine x plus pi over 2. So we know these are the values of x that we have on the scale, on the sketch. So if you substitute for when x is negative pi over 2, we're talking about 1 plus 2 sine 0. Because negative pi over 2 plus pi over 2, that is just 0. Sine 0 is 0. So we have 1 plus 0 giving us 1. So our point is negative pi over 2 comma 1. So we have a point here. From there, you substitute the next number 0. What is f of 0? F of 0 is 1 plus 2 sine pi over 2. Now sine pi over 2 is 1. 1 times 2 is 2. 2 plus 1 is 3. So we get 0.3. So we have a point there. Then we substitute pi over 2. So we have 1 plus 2 sine pi over 2 plus pi over 2. We'll get pi. Now sine pi is 0, so we'll get 1. So we have 1 here. Then you substitute pi itself. You have 1 plus 2 sine 3 pi over 2. Because pi plus pi over 2, that is 180 plus 90, which is 270. 270 is 3 pi over 2. But sine 270 is negative 1. So you have 1 minus 2. So we get negative 1. So we have negative 1 here. And then we substitute 3 pi over 2. So we get 1 plus 2 sine 2 pi. Because 270 plus 90 is just 360. Now sine 2 pi, that is just 0. So we get 1. So we go back to 1. And then we substitute 2 pi. We get 1 plus 2 sine 280 plus, sine 360 plus 90. That is the same as sine 90, which is 1. So we get 3. So we have the point there. What's on?
Hello, sir.
Hello.
Yes. How do you relate the radians to be 1, to be 3, to be 2? Like for instance, there it's sin pi, sin 3 pi over 2. Now, how do you get 3 pi over 2 to 1, to be 2 or to be 3?
That's we don't get them to be 2 to be 3. These are angles.
Yes.
3 pi over 2 is 270.
Yes, sir.
What is sine 270? Sine
It's
270 is negative 1.
negative 1, yes.
So you multiply negative 1 by 2. Okay. Because whatever is
So
negative 1 is this piece here. This piece has now been called negative 1.
Yes, sir.
So what we have is 1 plus 2 multiplied by negative 1.
Okay. So do you have to master the radians and the angles and how to rate them to negative 1 and to 1, or there's some special rules to it?
So as soon as I suspect that you missed the last class and you didn't make a follow-up of the video. Because we did so much on the angles. We have most of these angles. The reason why we need the scale is that the scale will always push us to the special angles. And the special angles are known. You must know sine 0, sine 30, sine 45, sine 60, sine 90, 180, 270, 360. And if a number goes beyond 360, like this one here, the one that we're about to have, here we're supposed to have x is 2 pi plus pi over 2. So we have gone beyond 360. So you look for its coterminal angle and get that coterminal angle now will help you get the value of sine that figure. And we did coterminal angles. We did reference angles. They are to be used now.
Thank you, sir. I'm clear now.
All right.
Sir.
Sir,
Uh-huh.
there are times when the range is not given for the x-axis.
In case by any chance the examiner forgets, you would sketch your graph up to just the initial period.
Okay. Okay, thank you, sir.
Mhm.
Sir,
You know,
as since we don't have special angles for 270, are you saying we're supposed to look for the coterminal angle of 270?
uh-uh. We have for 270.
No, we just ended up to 90. When it did 0, 30, 45, 60, 90.
Mm-hmm. What else did you do?
Special triangles.
We also did sine A plus B. So when you talk about 270, you can split it in this manner so that you have 180 plus 90. Okay. You don't know for 180, is it? You can as well say, okay, 90 plus 90. So you'd obtain them.
Okay, understand. Thank you.
Mhm. So this is this is the homework I gave you in, on that paper. Where the majority dodged to submit by telling me that the questions were very, very easy. Okay, so now after you have these points, then you connect them. Not the straight line, but a curve. And that is the sketch.
Why a cave, sir?
Because the sine graph is not linear.
All right.
Sir,
Sir, the line will pass through those points.
Yes.
Okay.
Mhm.
sir, where are we getting the -1?
Where are we getting the -1? We have an angle which gave us -1 here. This one, pi. Pi gave us -1, is it? It was 1 plus 2 multiplied by -1. So 2 by -1 is -2. 1 minus 2 is -1. Is it just my time or it's also a time? I thought I've just spent 10 minutes here. Can't this whatever?
Time is moving.
I was about to ask what is happening.
Time is moving fast. It's like you'll be voting soon. Eh?
Yes, sir.
Septizo?
Mr. Keith, you are so concerned about voting.
Why you want to vote bad, yeah? It's
People will
true.
pay.
Now you are going for bad this time.
yeah.
Have you heard what
There's a question.
Mr. Hancock?
Yeah.
What did he say?
Second question.
So you can continue.
Life difficult. Must sport.
Okay, let's do another example. So now there's a very close relationship between sine and cosec. If this very question, let me just mention it here. If this very question was asked in the form, this very question, if it came as f of x is equal to 1 plus 2 cosec x plus pi over 2. The same question, if where there is sine there, we had cosec. The working was going to be the same as what we have done here. The first step to make the working the same is where there is cosec here, you write sine and you start solving the sine graph. Go all the way up to sketching it. So now to avoid having more sketches, you choose to sketch this graph in dotted and then come back now to sketch. Your question is cosec. So you would go for the pivot points, these points here. Because so now you'd go to these points here and draw what we call the vertical asymptotes. You'd put the vertical asymptotes, and then flip this very graph. So where it is curving down, you pull it up. Where it is curving up, you curve it down. So where it is curving down, you curve it up. So this graph here is f of x is equal to 1 plus 2 cosec x plus pi over 2.
Sir.
Hello.
Yeah, why are you leaving some points like a pi there? Well, you're not considering it, but by drawing your horizontal asymptotes, I don't know why you are leaving some points.
You draw on the pivot points. You draw on the central points. The ones where sine was coming out to be 0. Like here, this was sine 0, is it?
Yes.
Sine 0 is 0. So when you are dealing with cosec, you know sine is in the denominator. So you'd get an undefined figure there. But on the other points, everything is just okay.
So you're not supposed to join them?
What do you mean join?
As in, like this whole graph is the graph including the one for the sine, or we're supposed to wrap the one for the sine?
It's also you wrap the one for sine, or keep it in dotted.
Then the ones for cosec, are they supposed to be joined or just like that?
No, those are don't join. They're just like that.
All right.
They're scattered in spaces.
Now, sir, I've got a question. If the function came as f of x is equal to 1 plus 2 open bracket 11 over 5.
Come again.
At f of x is equal to 1 plus 2 sine open bracket 11 over 5 pi x.
Yeah.
11 over 5
pi x.
And they ask you to sketch.
Yes.
You just sketch it. So we'll do it. Don't worry.
All right. Thank you.
So this is the, so now get the point. When they ask you to do cosec, your first step is to, where there is cosec there, you write sine and start doing all the working for sine. Sketch sine, and once you're done sketching sine, you realize that you're dealing with cosec, and then do this. You do the dotted, take it up, take it down. The one you take up and down is what you call cosec. So our next example is going to be direct on cosec. So 2, how do you do that? Example 1. This is example 2. Sketch f of x. Kindly mute. Sketch f of x is equal to is equal to 1. Let's turn around this change. Let's put -1. In fact, the 1 is okay. I'll change it to 2, and then I'll put the negative. I want a negative sign. -3 sine x plus pi over 4. Okay, so I've put sine. So I want us to sketch cosec. So we put cosec. So our solution will assume that we are dealing with y is equal to 2 minus 3 sine x plus pi over 4. So someone is unmuted, kindly mute.
So
Otherwise,
the interval.
we'll hear your secrets. For the interval, negative
Sorry.
pi
I was
over
just
4 to pi.
I'm sorry. I was wondering why you put sine there instead of cosec.
Okay. So I said, whenever you see the cosec question, your first step is to assume you are dealing with sine. Okay, let me go search for you. Okay. So David here. Yes. Okay. So we said when you're sketching, what do we need? We just need the period. So in this case is 2 pi over, over 1. So it's 2 pi. Then the scale, the scale is 2 pi over 4. So we have pi over 2. And then the horizontal shift, in this case, is negative pi over 4. So you can sketch. So we'll be dealing with so run from negative pi over 4 all the way up to maybe let's just extend our interval so that it becomes something nice. We'll see what happens as we flip there. Let's push it through pi again. Okay, so we'll start from the horizontal shift, negative pi over 4. Though, okay, everything is okay. It's also part of the interval. So from there, we are saying we should now get the other pieces. So negative pi over 4, we add the scale. The scale is 90. So negative pi over 4, this is just negative 45. Negative 45 plus 90, what do we get? We get positive 45. Pi over 4. Positive 45 plus 90. So what is 90 plus 45? That's 135. What's 135 in radians? So what we'll do is we'll take it in radians. So we're saying pi over 4 plus pi over 2. So it's going to be 4 down pi plus 2 pi, which is 3 pi over 4. So we'll have 3 pi over 4. And then we add another 90. So 3 pi over 4 plus pi over 2. So we have 4 down, 3 pi plus 2 pi. So we'll have 5 pi over 4. 5 pi over 4. We add 90 again. So 5 pi over 4 plus pi over 2. We get 4 down. So we have 5 pi plus 2 pi. So we get 7 pi over 4. So our next number is supposed to be 9 pi over 4, which is beyond 2 pi. So we just put 2 pi. Then we now bring in we're now looking for the y coordinates. So we can start doing the calculations. Our function f of x in terms of sine is 2 minus 3 sine x plus pi over 4. What happens when x is negative pi over 4? We'll get 2. So we'll have 2 here. The next thing is when x is pi over 4, we'll have pi over 2 inside here, which is 90. And that is just 1. So we get negative 1. So we come to negative 1. Let's say a point here. And then 3 pi over 4. That is 2 minus 3 sine 3 pi over 4 plus pi over 4. And that's just pi. So sine pi is 0. So we just get 2 again. We go back to 2. And then 5 pi over 4. So 5 pi over 4 plus pi over 4. we'll get, let's see what we get. 5 pi over 4 plus pi over 4. We get 6 pi over 4, which is 3 pi over 2. Now this is 270. And 270 is negative 1. So negative 1 times negative 3, we get positive 3. So positive 3 plus 2, we get 5. So go to 5 is a point there, meaning that the other point is going to come here. And then the intervals ended. We have this one, which is not obtained from the scale. So we need to solve for that value there. So what is f of 2 pi? That's going to be just the same as the value of 45. Is it? Because we have 2 minus 3 sine 2 pi plus pi over 4. So mean the coterminal angle here would be pi over 4. And we know that that is root 2 over 2. So is it positive or negative?
It's negative.
Yeah, sure. Punch it somewhere. Then look positive, then look negative.
It's positive.
It's positive, sir.
It's positive. So it's no, not going to be difficult to sketch there. It's supposed to be negative.
It's negative, sir.
Let's go through, sir.
It's negative, sir.
It's negative what? The guys. Okay, let me check. Let me check 2 by root 3. 3 point something. It's positive. So this number, when you divide this number by 2, to 1.7.
No, it's negative.
No, a final answer should be negative, not positive.
It's negative
Wait, sir,
0.1.
try again.
Yeah, that number is about
Because you said
something.
root 3.
It's negative
2
1,
minus
sir.
3 by 3. Yeah, I don't trust now. 3 by root 2. Okay.
Let us use 9 pi over 4.
Okay, I've gotten it. It's negative. The final answer will be negative.
Oh, sir.
So 3, because 3 by root 2 is 4 point something. Divide by 2 to be 2 point something. So 2 minus 2 point something, you get negative 0 point something. Exact. So it will be negative. So let's sketch. Remember we are dealing with, so me, I can use, because I've got different colors, so I can do it in bold. Where's my first point? Let's go on somewhere else. Okay. My first point is here. Okay. So crossing there. Hitting here. Come down and hit here. So I don't know what this value is, so I'll just end my point here. Then I realize that I'm dealing with, my question is cosec, not sine. So I'll come to this guy and put on the middle points, I put the dotted numbers. Dotted here also. Dotted here also. Then we sketch. So the one that is going up, you pull it down. And that is going up, you pull it down. And that is going down, you pull it up. It never touches red lines. So this is our sketch now. F of x is equal to 2 minus 3 cosec x plus pi over 4.
Sir.
Hello.
So, the last point, the one for 2 pi, it's just to, like, it's okay if it, how can I say? Like, it's okay even though you don't, like, place it exactly where it's supposed to be. Just leave it the way it is, not a point.
It's not that okay. So place it where it is as 2 minus 3 root 2 over 2. So all the points must be clearly known.
Okay.
So me, I have so far we have done 4 examples. Is it?
Yes.
Yes. Alright. So if this question was ending here, if it was this question, so if the question came just like this, would have sketched up to here and indicate that this guy is equal to 2 minus 3 sine x plus pi over 4. But if it came the way we have it as cosec, then you just label the one that is cosec. You don't label the dotted one because it would be useless. You just needed it to get to your required sketch.
Sir,
So,
yeah, for the horizontal shift, is it okay if we were to add the horizontal shift, add and subtract by the amplitude, and put the horizontal shift on the middle?
vertical, not horizontal.
Yeah.
Yes. Now that method, I don't encourage it because it forces people to memorize, and you get stuck if we temper with the.
Hello, sir.
Hello.
Can you sketch the graph of sine into dot form, then the graph of cosine into cosecant into normal form?
Yes.
It's fine.
Very fine, actually.
Okay, thanks.
Or the other one, you can sketch it using a pencil, and then when you're then the other one you use a pen, and then you erase the pencil part. Or keep both and label. Use the labels.
Excuse me, is there an
Hello?
alternative way of answering such questions?
Yes, there is. Alternatively, I tried to explain this. This is the one I was using now. F of x is equal to -2 plus 4 sine 2x minus pi. Or maybe minus pi over 2. Do something like this. Okay. So you want to sketch this, so you get to know the amplitude modulus of 4, which is 4. The period 2 pi over b, which is 2 pi over 2, which is pi. Then the scale is pi over 4. Horizontal shift is positive pi over 4. The vertical shift, -2. So just from these, my sketch is complete. Bring it here. Amplitude is 4, so you have 4. You also have -4. And then you have 0. Since the scale is pi over 4, you have 0. You have pi over 4. 2 pi over 4 is pi over 2. And then 3 pi over 4. And the end at pi, which is the period. So if the interval is from pi over 4 all the way up to 5 pi over 4. So we'll add also, we get 5 pi. All the way up to, is it 5 pi? Okay, yes. 5 pi over 4. So what you do is, you're doing sine. So when you're doing positive sine, you first sketch the graph of sine within this period, knowing that in the critical points, it should come out like this. You don't need to calculate these coordinates. As long as you have used the scale and you're starting from 0, that's how your graph will come out. So you put this in dots. This is sine. You've only used the amplitude and the period. You've also used the scale. We haven't used the horizontal shift and the vertical shift. So let's use the horizontal shift first. So you move, when the horizontal shift is positive, you move each point of the original sketch pi over 4 steps to the right. Meaning, we'll move 0 to this point. We'll move that one there to this one. We'll move this one here. We'll move the other one here. And we'll move this guy here. So we have another one. The third sketch will be our final one. We now move vertically. So we are done with this piece. We're remaining with the vertical shift. So -2 steps. So you subtract 2 from each of the coordinates. So -4, it will become -6. 0 will become -2. +4 will become +2. And then you sketch again. So you move points. This point that was at 0 will come here. The one there will come to 2. The other one will come to -2. And then to -6. And then to -2. And then you have your board sketch now.
Sam, I'm totally behind up.
And label it.
So, get, because all the figures have come.
You make option. And -5. So this is option number 2. I was answering a question of, is there another way of doing this? This is another way. So this way requires you to know, you need to know the amplitude and its meaning. You need to know the period and its meaning, the scale, horizontal shift, and the vertical shift. And you are shifting the original graph of sine. But the other method, you just need to know the period, the scale, and the horizontal shift. Then it will do the shifting for you, because you'll be getting the actual points, you're getting the actual y coordinates. So by the time you plot them, you would see, because here you can't even see the meaning of the amplitude and the like, because everything has been done by the solving of points. You can't even tell what the amplitude is here if you don't know its meaning. Meaning that I can sketch this thing without understanding what it is if I use the solving of coordinates. But not for this one. I can only get this one if I understand the meaning of every property of it.
So, sir, for this one, you can also sketch the one for cosec using this one.
Yes,
this method.
Since we said we go all the way with sine until we are done with sine, then the last graph of sine is what we flip up and down. So if it was cosec, when you get to this point, then now you involve the vertical asymptotes, and then where it faces up, you take it down.
So we use the one for, so here we use the blue one, the blue line.
We use the one, yes.
Yes.
Okay.
Zach, can you demonstrate cosec on this one?
Demonstration is nice. Okay, let me demonstrate. So we have moved the 0 line to -2. So I'll follow it. So this would be my dotted asymptotes. The other ones will be, and the other one will be. So I'll take it down, and I'll take it up. That's all. This graph here is f of x is equal to -2 plus 4 cosec 2x minus pi over 2.
So, sir.
Mm-hmm.
Hello? Yeah,
Hello.
I was just trying to find out, like, this problem, can we solve it using the previous method we were just using?
Yes.
Oh, okay, yanipene sakwe naluba nako.
So because the previous one, it will just land you in the blue line. You only have the blue curve with the previous one. And then your next thing, if you want cosec, you move to cosec.
Okay, sir.
Sir,
Mm-hmm.
when we are shifting using this, do we still need to add the horizontal scale, or how are we getting those points?
What do you mean by the horizontal scale? The horizontal, we only have the horizontal shift and not scale.
Yeah, I mean, sorry, the horizontal shift. Do we use that one, or how are we getting those points?
So you use, that's what I'm saying, when you're using this method, you need to understand all the properties and how they are used. So the amplitude is your stretch for the original curve. The original curve is the one that comes direct from the period and the scale.
Yes, sir.
So after we have this one in black, it moves from 0 to 4, from 0 to -4. And it's starting from 0. There's no shift there. Then now you go to your shift. Horizontal shift is positive pi over 4, meaning you shift all the x coordinates pi over 4 steps to the right. So what is at 0? You move it to pi over 4. So you keep moving by pi over 4 step for each point. Then the vertical shift, you move the y coordinates by 2 steps down. Then you sketch your graph.
Okay, sir, I get the point now.
So now, sir, I'm a dotted line. Are they important? The dotted lines one, like for black, lead, and yeah.
If you use this method, yes, they're very important because they are the working part. Sure, working, that's the working part.
Now, sir, I wanted to ask, like, in terms of that from the one in the black, the dotted line in black, is it standard because we're starting from 0 and then the interval there is no 0?
Yes, that one is standard.
All right, thank you.
So what we'll do is I'll just give you an exercise and then you are good people. I know you won't submit, but you will solve.
We're good people. Definitely will submit.
All right.
Sir.
Hello?
Yes, sir. I've got a question here. Maybe we will shed more light after we do it. I don't know if we can do it.
Read the question.
Given the function f of x is equals to 1 minus 2 sine open brackets half x minus pi over 6. Find the amplitude, period, phase shift, and vertical shift, and sketch its graph in the interval 0, 2 pi.
Find the amplitude, phase shift. Now phase shift
and vertical.
So when they say phase and vertical, the phase goes for horizontal. And vertical shift, period. Then sketch. Sketch f of x. From 0, what's the interval?
0 to 2 pi.
What? Edward, what was your question?
My question.
Mm-hmm.
My question was like you've given us like 1 minus 2 sine,
Mm-hmm.
open bracket, 11 over 5 pi x closed.
And then they ask you to sketch.
Yeah.
Okay, so here, so this question, you can only see it where you saw it from. So this is not, it's not that complicated though, but it's not nice. It's bad. Hence sketch on the same let's do this on the same graph f of x is equal to 1 minus 2 cosec half x minus pi over 6 on the same sketch. Then 2, you will do f of x is equal to minus 2 plus 3 sine. Okay,
That's
this
an
one,
exercise, sir.
yeah, these are exercises. It's an exercise question. Cosec.
Oh, so phase shift, is it horizontal shift?
Yes, phase shift is horizontal shift. Sketch. This one I wanted to start it from pi over 3. This will equal to okay, so you have this as an exercise. Question 1 and 2. So the first one, you're sketching sine. You're also sketching cosec for the cell. The second one, you go direct to cosec, meaning you sketch sine automatically. So don't erase sine. I want to see it. So that you would have sketched 4 in 2 questions. This is 1930. I'm sure it'll be done by 20. So there are no excuses. It'll be done by 20.
So we have to submit right now.
We are submitting at 21 hours.
So our class ends at 21 hours and this timetable. So 30 minutes has been assigned to an exercise. No excuse.
But what I'm doing to submit today?
This class was supposed to end at what time?
20 hours.
20 hours.
And this is 1930, is it?
Yes, sir.
Yes.
So the class is ongoing. So the other part of the class has been given on exercise. So no excuse. You submit within 30 minutes. You submit the work.
We
But
are
at 20 hours,
cooking.
we end the class.
Hmm.
You can't be you can't be
Good
cooking in
God.
class.
Sir, so we can make
Advantage.
question one we submit and then the other question we submit later.
We are supposed to be learning up to 20 hours,
Yes, sir.
as we agreed.
So I can't do tomorrow.
Okay,
So
you
we need
submit
time
the
to
work
sit. And
tomorrow.
then this time from
You submit
now
the work tomorrow.
to
That sounds better.
Okay,
Yeah.
look.
Yes, sir.
Yes, I promise. I promise. I will submit
You
tomorrow.
submit tomorrow,
Promise.
but then you
Yes,
need to
tomorrow.
continue in class up to
tomorrow. Yes, sir, tomorrow.
Ah.
Yes, sir.
then
Yes,
you
sir. No
continue up to
problem,
20
sir.
hours, right?
Can't submit at 20
Bana,
rate.
no problem, bana,
Submit.
guy.
Okay, sir. Let's just submit
You
the
can just
20
submit
hours.
then, no,
Anyway.
sir.
you guys look. We need to agree. It's 2 hours too much for them.
Sir, we are going to submit. Let's just answer the questions.
Answer the questions.
Okay. You answer that. Because there's no need of running away from submitting. Because tomorrow we have a class again for 2 hours.
Actually, we are just wasting time, sir. Let's just start answering.
Hmm.
Then we submit
Good.
by 20 to 2010 somewhere there.
All right. I can give you some time. You can submit it. Okay, you can submit before you can submit when you are done. But I wanted you to use the 30 minutes which I have given for class to do the work.